Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we are going to have an overview of thermal loads on members. To add loads on members, we use the command Member Loads from this menu on the Addition toolbar. We click on the tab Thermal, and the process to add a thermal load is similar to the process of adding any other type of load. First, we select the member. Next, we create a basic load or select a basic load from this menu. If the basic load has not been created, we click on this button to create the basic load. The next step is to select the gradient along X, Y, and Z. The gradients along X will lead to a change in the length of the element. A positive thermal gradient will cause an elongation of the member. A negative value will cause a shortening of the member. Typically, this gradient is equal to the difference of the temperature during the construction and the temperature of the service. For example, if the element is at 15 degrees during construction and 20 degrees in service, the thermal gradient will be equal to +5. The other two gradients, the gradients along the Y and Z axes, these thermal gradients will lead to the bending of the elements according to the strong and weak axes. A positive thermal gradient occurs when the temperature at the positive edge of the section is higher than the temperature at the negative edge. For example, if the temperature at the bottom of the section, negative internal Y direction, is lower than the temperature at the top, which is the positive internal Y direction, then the gradient will be positive. A positive gradient will induce an elongation of the material at the top of the section and the shortening at the bottom, which will tend to bend the elements upward for a simply supported beam. In this example, for this beam, to apply a longitudinal gradient along the x-axis, we will specify a gradient, for example, 25 degrees. We select the beam and we click on the button Add. When we apply a longitudinal gradient along x, we see this arrow that appears on screen that points towards the end of the member. If we want to apply a gradient along the y and z axes, we do the same process. We select the member and then we add the value of the gradient, for example, 25. Then we click Add. In this case, the thermal load will be displayed this way. For this example, the only load applied on these two beams is the thermal load. Let's run the analysis. We display graphically the axial force Fx and the bending moment Mz and the internal deformation. We notice for the beam with a longitudinal gradient along X that an axial force develops in the member even if the deformation and bending is equal to 0. For the beam and the transverse gradient along the y-axis, we can see that this thermal load caused the deformation of the beam, and we notice that the axial forces are equal to 0. However, the bending moments Mz is at a maximum at the midpoint of this beam. Keep in mind, as the program makes the assumption that the thermal gradient is linearly distributed between the extreme fiber of the cross-section. Transverse thermal gradients are not allowed on angles, pre-tension cables, and plate sections. In the case of steel concrete composite beams, only gradients along the internal y-axes are allowed. Thank you for watching, and catch you in another one of our webinar series videos.